Today is the 15th of the 9th, 2023, and we would like to look at our third lesson on sequences. Okay, and today we want to see how to deduce the position to term rule, and we'll do some examples. Thank you very much for everyone who has been watching our videos. Okay, I'll appreciate it a lot if you subscribe, share, like, and follow us, depending on which platform you are watching from. I normally write, please follow my notes/scripts in the comment section. Okay, so for instance, here I have 23, 20, 17, 14, 11. Okay, so assuming I say 2023, it is not follow the script, because what I'll be explaining will be 20, 23, 20, because we are doing sequences. Okay, so the order matter. Okay, so it's 23, 20. Okay, now beware of scammers. They are everywhere. Okay, beware of them. If you are online, be careful. If somebody sends you a friend request and give you a familiar name, okay, like my name, and start chatting with you and sending you foreign numbers, it's not me. Okay, and asking you to donate money for a charity, orphanage, a very sick person somewhere, it's not me. Okay, I don't have a charity, an orphanage, and I'm not collecting money for charity. Okay, if I have to do that, I'll do that personally. But apart from that, don't be scammed. Okay, there are a lot of charity out there that advertise for money and stuff. If you want to give to charity, that will be your business. Now, recap. We've done 2 lessons so far on sequences, and we've seen that sequences have rules. Okay, we need to deduce. Okay, so for example, the sequence here 1, 13, 25, 37, 49. If you see, the rule is add 12. So when you add 12, you get the next number. Okay, and it stops. Okay, and we said a sequence that stops is called a finite sequence. The one that doesn't stop, that we use 3 dots, is called an infinite sequence. Okay, now so the rule here is plus 12. There is another sequence here, 23, 20, 17, 14, 11. Now here is decreasing by 3. Okay, 23 minus 3 is 20, minus 3 is 17, minus 3 is 14, and minus 3 is 11. Okay, so the rule is minus 3. Okay, and yesterday I said there are two types of sequences. Okay, and what we are looking at are linear progression and under linear sequences, and under linear sequences we have the arithmetic progression, which deals with things like +2, add 2, -2. So if it is adding or subtracting, then it's an arithmetic progression. If it's multiplying or dividing, then it's a geometric progression. Okay, so but it's linear. So if it's adding, subtracting, then it's arithmetic. Okay, so the first two example is linear arithmetic progression. It's adding or subtracting. Now here is a times 3. Okay, so 1 times 3 is 3, times 3 is 9, times 3 is 27, times 3 is 81. It's still an ordered sequence. The example of 8 is times 3, and these types are geometric, so but they are also linear. Sorry. Divide. So 200 divided by 2 is 100. Divided by 50 is 100 divided by 2 is 50. 50 divided by 2 is 25. 25 divided by 2 is 12.5. So this is an example of dividing a sequence. Okay, and this is also a linear sequence, but this is the geometric type. So when it's timesing or dividing, it's a geometric linear sequence under geometric progression. And then we saw a third one. So this one here is an example of the multiplication, and this one is the example of the divide. And then we saw a second type, which is not linear, but it's a quadratic sequence. Okay, and normally you have the rule like 3n squared or n squared or n squared plus 2. Okay, so here the rule is 3n squared plus 1. These type are quadratic. Immediately you see the square sign, you know that it's quadratic. So 3n squared plus 1. Okay, so the first term is 1. So n equals 1. Okay, so 1 squared is 3 plus 1 is 4. N is 2. That is the second term. So 2 squared is 4 times 3 is 12 plus 1. N is 3, third term. 9 squared is 4. 3 squared is 9. Times 3 is 27 plus 1 is 28. 4 squared is 16. Times 3 is 48 plus 1 is 49, and so on. So if you look at the first term, n equals 1, n equals 2, second term, n equals 3. So with this rule, okay, you can find n equals 100. Okay, so this is a type of a quadratic sequence. Okay, so for our starter today, before I introduce you to what we are going to do, okay, solve. Okay, we've seen similar of this when we put the variables together. So solve r plus 3x plus 4p minus 5s plus 6r plus 5p. Okay, so now we put the r's together, so there's an r here and an r here, so we have r plus 6. Okay, 3s here and minus 9s here, so plus 3x minus 9x. 4p here plus 5p. So here, as I've explained before, you are putting tomatoes together, oranges together, apples together. Okay, so r plus 6r is 7r. 3x minus 9s will be minus 6x. Okay, plus 4p plus 5p will be 9p. They don't have any common factor here, so that will be an answer. So 7r minus 6x plus 9p. Okay, we've done some examples on this in our algebra video, so if you are not sure, just go back and watch it again. Today I'm going to do lots of examples with you and deduce how to find the position to term rules, because I introduced you to it yesterday. Okay, so if we see a number sequence like this, as we can see, 4, 9, 14, and 19, there is an increment of 5. Okay, but if we want to find like the 1000th term, are we going to be increasing by 5 till we get to 1000? Okay, that would take all the day. Okay, so how do we do that? Now, n here is the first term, so our first term here is n. So n here is 1. Okay, second term is 9, n will be 2. Okay, n is not the number. Okay, so first of all, we know that the difference is 5, increment of 5, so we write the difference. Okay, the first term n is 1, so our first term here is 4. Sorry, the first term here is 4. Okay, but n equals 1. Okay, now the rule is 5n minus 1. How did we arrive at that? I'm going to explain. So there's an increment of what? 5. Okay, now I've given you the straight on rule, but if n is 1, okay, then straight away we have 5n, because there's a difference of 5. So if n is 1, we have 5 here. What do we do to 5 to get a 4? We take away 1. So that will be our position to term rule. And if we apply to all the numbers, it should hold. So let's have a look and see. So if n is 1, okay, 5, that is the first term. 5 times 1, because there's an increment of 5. 5 times 1 is 5, minus 1 is 4. So that will be the 4 here. N is equal to 2, okay? So 5n is 5 times 2, 10, minus 1 equals 9. So that will be our 9 here. N equals 3. So 5 times 3, 15, minus 1 is 14. So that will be our 14 here. N equals 4. Okay. So 5 times 4, 20, minus 1 equals 19. 19. So if we want to find the 200th term, it will be 5 times 200 minus 1. So if n is 200, that will be the 200th term. So 5 times 200, which is 1,000, minus 1, which will give us 999. So that is how I got this rule here. 5n minus 1. Okay, that is how I got this rule here. Okay, so we've seen that. Okay, so we solved that. So in a short space of time, we can find the 200th term just by finding the position to term rule. Okay, now the second example. Okay, so we are going to use the same principle. The first term here is 12. Okay, the second term is 19, 26, 33. So 12, when we add 7, we get 19. When we add 7 to 19, we get 26. When we add 7 to 26, we get 33. So we have 3 dots, which means it's infinite. It goes on and on. Okay. Remember, the comma is because in sequences we separate each of them by a comma. That is our mathematical symbol here. Okay. So first of all, to find the position to term rule, you need to first find the difference, and we realize that it's add 7. So now we find the difference and multiply by n, where n is its position. Okay, so the first term n is 1, second term n is 2, third term n is 3, fourth term n is 4. Okay, so this is our term. So now there's an increment of 7, so we multiply by n. Okay, where n is the term or position in the sequence. So if n equals 1, we have 7. Now, what would you do to 7 to get a 12? You add 5. So straight away, our position to term rule will be 7n plus 5. Okay, and it should be true for all these other numbers. So our rule here, our position, okay, to term rule here is 7 plus 5, because there's an increment of 7 and 7n. So n equals 1. If we add 5, then we get 12. Now we have to test and see if it applies to the other numbers, which you can easily do on your calculator. Okay, so let's see. 7n plus 5. So when n is 2, we have 14 plus 5, which will give us 19. When n is 3, we have 3 times 7, 21 plus 5, which will give us 26. When n is 4, 7 times 4, 28 plus 5, which will be 33. So if we want to find the 126th term, n here is 126. So 7 times 126 plus 5 is 887. You can use your calculator and check. Okay. There. So therefore, the sequence is 12, 19, 26, 33, and the 126th term is 126. So we can decide to skip terms, find the position to term rule, and use it to find whatever term we want. Okay, so the rule here is 7n plus 5, which is also a linear progression. Okay, so there you go. So n equals 1, n equals 2, n equals 3, n equals 4, then n equals 126. We don't have to do in between. Okay. Now another example. So consider the number sequence 1, 8, 15, 22. Okay. Determine the position to term rule. Use it to find the 225 term. So 1 plus 7 is 8, plus 7 is 15, plus 7 is 22. Okay. Now, I'm supposed to find the 225th term. Okay. It looks very small, but it's 225, as we can see here. Now, so straight away, the difference is 7. So, straight away, the first part of my position to term rule is 7 times n. Okay. Now, when n is 1, 7 times n is 7. What would I do to 7 to get a 1? Okay, I need to subtract 6. So my rule now is 7n minus 6. We need to find out if it applies to the other terms. Okay, so 7n minus 6. When n is 1, 7n will be 7 minus 6 is 1. So there. When n is 2, 7 times 2 is 14, minus 6 is 8. So that will be my second term. When n is 3, 7 times 3 is 21, minus 6 is 15. Okay, so 21 minus 6 is 15. That will be my third term. When n is 4, 7 times 4 is 28, minus 6 is 22. So 22. So now, to find the rule here applies to these first four numbers. So to find the 222 term, n will be 225 term. N will be 225 term. So 7 times 225 minus 6. If you do it on the calculator, you get 1569. Okay, you can try it. Okay, so now this will be 1569. Okay, so another example here. So the difference you multiply by n, okay, and then use the first term that you have and see what you add or subtract to get that number, and that will be your position to term rule. Okay, so yeah, okay, so that will be your position to term rule. So the next one here, okay, just a minute, I'm having a look at something. Okay, okay, so we've done that. Okay, we've looked at that. We've done the 225 example. We've done this one. So we've just done that. Okay, so we have another one here. Okay, so we have plus 7. Okay, so what will be the third one we have here? Sorry. Okay, so we have 12, 19, 26, 33. Okay, and then it's an increment of 7. Okay, so we have we want to find the 126 term. So there is a difference. We multiply by n. Okay, because there's an increment of 7. So 7n. What do we do to 7n to get 12? We add 5. So that's how we got 7n plus 5. Okay. And when we tested it, we realized that, yes, so we can find n equals 126. So 7 times 126 plus 5 is 887. So 7n plus 5. So 7 times 1 is 7 plus 5 is 12. Okay, 7 times 2 is 14 plus 5 is 19. 7 times 3 is 21. Okay, plus 5 is 26. 7 times 4 is 28 plus 5 is 33. Okay, so if n is 126, then 7 times 126 plus 5 is 887. So we don't have to count till we get to 126. Okay, so our position to term rule here is 7n plus 5. Okay. Now our last example. So here we have 1, 8, 15, 22. And then we want to find the 222th term, which I've already explained. Okay, so 7n minus 6. So if you test it, it's right for all of them. So to find the 2225th term, we have 225 times 7 minus 6, which is 1567. So all we need to do is to find whether it's increasing or decreasing. If it's increasing, we multiply by 7. Then we look at our first term. What do we do to get that number? What do we add or subtract? And that will be the second part. Okay. So I hope I've managed to explain this to you. Okay. So today we've done some recap. Sequences are ordered numbers with rules, and we have to deduce these rules. These are straightforward, so we can see. But if we have to find missing numbers, for instance, 2 or 3 numbers, it's easy to do that. But if you want to find the 100th or the 250th or the 75th position, then we need to use the position to term rule. So that's what I've tried to introduce you today. Okay, so we did this data in algebra, which we've done several times, putting variables together. So we find the difference, multiply by n, when n is the position in the term. Then you see what to add or subtract to get your first term. If you get that equation, you test and see if it applies to the other 4 numbers with your calculator. And if it applies, then you can use that rule to find any term you've been asked to. Okay. I think so far we've exhausted our example for today. So thank you very much for watching today's lesson, and I'll see you in the next.